Draft physics presentation. I guess we'll do the Pyrrho video, as promised, kind of. Save the comments for the next video. Whatever. So yes, let's on with the show. I guess as a preface, it should be understood that the standard model is just a guess, just a shot at it. So 100 years ago, they had a certain number of facts about, experimental results, and they could attempt to draw certain conclusions about what model would fit those results. And the real problem with the physics is that they accept everything whole. Like, once they accept it, it can't change. They can't modify things very well. They don't critique their models very well. They just choose one, and then they stick with it. And then they just kind of attempt to rationalize it or defend it. If anything new shows up, to say, well, maybe that's not quite right. And so that's all he's really defending, is some cobbled together different pieces to try to fit together a mechanism. And so they've kept archaic bits, almost as bad as Benjamin Franklin's 50-50 bad guess at plus and minus. And even though it's wrong, you can't fix it. You can't change it, because too many things have been built upon that mistake. And so now you have current going one way and voltage going another way in wires and all kinds of stuff that just is kind of silly. And but because they've engineered it all on top of this stuff, it works because it's engineered wrong to fit the wrong. And that's all I'd say this is. Just a bunch of, I won't even call them assumptions, just some declarations, guesses, notions. I don't want to insult the process. I mean, it is difficult to make models when you can't see very well. So it's like, you have a little bit of information and you're trying to say, well, what exactly does it look like? It's like painting from a bad photograph, and you're not sure you're going to get the essence of the thing, because you just don't have enough detail. So I'm not saying these people are all wrong. I'm just saying that obviously the scientific method is sort of the Newton example, where you're cautious and not reckless. So you go with what you know, and you speculate about other things, but that's all it is speculation. You say, no, don't write this in stone anywhere. Don't chisel this in. So you have to now, you have to try to make the letters fit, even though they're the wrong letters.
I thought I would commit a little bit to a model. Basically, I think the photon is when you have...
Yeah, thank you, YouTube. I mean, it's not much, you play 10 seconds of the video, thank you. And it'll somehow try to blame my connection, which is just bullshit. I noticed this was happening on my tablet, and I kept thinking, oh, maybe the connection's bad or something, and I'm like, no, it happens on your regular computer too. This is just some of YouTube's horse shit.
So I thought I would commit a little bit to a model. Basically, I think the photon is when you have...
Oh, cool. it pooters out at exactly the same moment. That's pretty funny. Come on, play the fucking video.
So I thought I would commit a little bit to a model.
Don't touch it.
Basically, I think the photon is when you have the orbitals in a higher energy state, and then they drop to a lower energy state. They send out a certain amount of energy.
Right, and there, you have no description of what this energy is, and that's the whole problem. Okay, they send out a certain amount of energy that comes from where, that is produced by what. So just like gravity and your virtual photon, which you're now describing. So you're saying the photon is a virtual photon, even though we know there's a difference between real photons and virtual photons. And you should be able to tell us what the difference is. You should be able to acknowledge that you just can't make energy out of nothing. And that's all you're doing. And it's because your model isn't right, that you're stuck with no explanation for how it happens. I didn't have an explanation of how it happens 10 years ago. Just some sort of notion that, okay, there's some sort of energy that's in there, and somehow that energy gets released. But I didn't have any place for it to come from either, because I didn't have enough. I didn't know that they could be wrong, and I didn't know how little they were basing their conclusions on, and that you could really start over. That it really was realistic to go all the way back to the beginning and say maybe this whole model of the atom is a bit off.
So the weird thing is, since energy isn't a continuous thing, you can't divide it as the circle of the energy goes.
You can't divide it, and you also aren't allowed to just make it up. You're not allowed to inject it into the universe, without a cause. If you're doing physics anyway, maybe you can do that if you're doing metaphysics. God done it. But if you're supposed to be doing physics, you're supposed to be explaining how it happens, what exactly takes place.
Goes out as the ripple. You can't divide it.
So again, we know photons don't go out as some kind of ripple. So this is just more mush. I mean, this model or idea, the idea of the rays of sunlight is kind of an old idea. People drew it that way. And it's accurate. And it exactly fits Maxwell's mathematics in terms of that's how force works. It radiates from an object. And in certain locations, you can draw a field line, and the field line is just a representation of the strength of the ray at those distances. So when I put more than one thing in the image, I'll get a funny looking line because there's two objects creating rays, and the rays are essentially just pressure. And you can draw the pressure line like a topographical map. But that line is made out of rays of straight line force, not percussion, not it comes out of all the sides at once. A photon is a discrete thing, moves from point A to point B. It doesn't move to point everything, point A to Z. It doesn't do that. An individual bit of energy, quanta, doesn't do that. The evidence demonstrates it doesn't do that.
Because there's a minimum amount. It's either zero or it's a whole amount in a particular area. So that's weird, and that creates...
So, just so vague. So there's this vague notion that an electron moves from this is his physics. It moves from an energy level for unknown reasons. In doing so, in moving, it radiates a bunch of stuff in some circular way. Do we even know that electrons are circular? And somehow, when that all or nothing wave, that wave of light, photon, when it goes somewhere, we only detect it in one location. The rest of this doesn't go anywhere. Just one little place in space is going to be affected. One tiny, tiny, tiny piece of space is going to be affected by this.
It's the idea of a photon, which I think is just entanglement.
So now it's just entanglement. So it's a wave of entanglement or something. How do you even bring up entanglement in this subject? The photon and momentum travels from one object to another object. And all the experiments indicate that it lands in one location, a tiny discrete location is where the energy ends up. That's what all the experiments indicate. So how do you... What's entanglement have to do with it?
Tangled with having detected the ripple at this location, somebody else at a different location could be entangled with it at a different.
So we know that it takes time for the momentum to get from one place to another. So this entanglement argument can't mean anything, because we know it takes time for it to travel, that it actually has to travel through something. And I can put different substances that it will get through and substances it won't get through. And there's no entanglement here. There's no special instantaneous reactions. There's just absolutely no physical evidence that we can make something instantaneously happen in one location and make something happen in another location. There's no evidence of that. No hard evidence.
Location, and they would have a different set of information that entailed based on the entanglement.
Right. So I'm just saying there's no physical evidence in the sense that there's, they have this theory that this thing is, useless entanglement. So in the practical universe, you won't be able to detect this event of somehow this creating this without this having to actually move to this. And so there's no evidence that anything other than that happens. Something has to go from point A to point B to transfer information. You can't make information anywhere. So he's basically just speculating that there's some opposite planet on the other side of the sun that's exactly the opposite of the Earth, because every electron is an anti-electron, and every photon is an anti-photon, and everything's opposite polarization. So if it's polarized vertically in our Earth, the same photon is polarized horizontally in their Earth. And he's just making it up. There's no physical evidence that anything like this ever happens, that there's any inverse universe, that there's this entangled inverse universe existing somewhere. It doesn't exist. Just made up. I mean, I can't disprove it because I can't disprove God. I can't disprove an invisible, meaningless universe that's entangled with this one.
Entanglement's easy to destroy in nature, but the human brain, being an entropy pump.
Entropy pump. So whatever that means. So the human brain is an entropy pump, in the sense that, the human brain burns a hell of a lot of energy. So I don't see how it really has an entropy problem, in the sense that it takes in potential energy, kinetic energy, turns into potential energy, and then uses that energy to produce neural activity in the form of mostly in terms of electrical conveyance of information.
Maintains entanglement. That's what information is entanglement.
So information is entanglement. The two things just really don't have anything to do with each other. A computer doesn't work because it's entangled. The bits have to travel. That's why the computer takes time, is because the electricity has to cover the pathways. It has to go to the boxes. It has to go to the memory locations. It has to go to places to get the information. This is all just a pile of made-up mush. This is not physics. It's just some other subject. But again, he's arguing as if, this is the model that compels him. I don't think regular physics is even this far gone, in terms of they would start bringing up this entanglement crap as being some vital function, that without it the universe doesn't work. I think most physicists know that you could blow up entanglement, you could throw it in the trash or the bin, and somehow the universe would still function.
So, basically, my model is that the photon is an ephemeral phenomenon.
So I don't want to go look up ephemeral, but it doesn't sound good. It doesn't sound like physics. Doesn't sound like anything but a fucking religion, ephemeral. What the hell does that mean? It either is or it isn't. It's a thing or it's not a thing. It's a cause and effect universe. Why don't you just say you don't believe it's a cause and effect universe, that you don't need causes, that you have things that can just poof, and they poof out, and they poof in, and they poof out, and there's a grand poofer somewhere. Is that what you believe? There's a grand poofer mechanism, Or is the grand poofer some multiverse or altoverse that's somehow influencing this verse with a bunch of noise, a bunch of poof noise? What the fuck does this crap mean? How the fuck do I write this on a piece of paper and say this is how the universe works? What does this? Where's the chain, the link of this is like somebody describing evolution and saying, parameciums, elephants evolved into parameciums. I mean, it's so backward and crazy.
Phenomena that's a cross section essentially of the full data set.
A full data set. I mean, this language. What is it? It's a cross section of a full data set. What does that have to do with electrons and photons and protons? I mean, it's just such a crock of shit. A full data set
Comes from whatever is causing this weird quantification.
Whatever's causing the weird quantification. So the fact that he needs to have a cause for the elemental bits, again, the reason why it's quantized is because they're discrete and small. That's why we can't see them, is they're really small. They're small. But again, he doesn't have, as he just described, you can't make this into a discrete bit. You can't quantize this. So I guess he's saying whatever turns this into a straight line between point A and B where the damn photon lands.
The energy. Now, as weird as the quantification of energy is,
So again, there's absolutely nothing weird about it from my perspective. Okay, certainly made sense to me. The rest of the universe looks pretty quantized. The comets are quantized. The meteors are quantized. All the matter is in clumps. Now, there's no standard clump size, but the universe is big and the small universe is small, and the two aren't the same thing. So it's clearly kind of obvious that I'd say the big universe, with the empty space and the clumps, it's the same thing in the small universe. The same empty space exists, and there's clumps in it, and the clumps are more regular. They're obey rules that confined. They're more. They're made out of building blocks. The building is made out of bricks. Bricks are different than buildings.
We know if energy was continuous, we would have had this thing we had called the ultraviolet.
So again, this is like their straw man argument, that you had some expectation that energy is released in the same amount of energy will be released in the easy to do form, like I can move my finger. So the argument is, okay, so I can move my finger slow, really easy. Oh, that's so easy to do. But going like really, really fast, like speed of light fast or infinitely fast or something, oh, that's really hard to do. Yeah, it's really hard to make a movement really, really, really fast. And so we're supposed to believe that it was a rational assumption to say there should be just as many people who can do this as there are people who can do this. So it's like saying that some people can high jump like 7 feet or something, whatever it is, 10 feet. 7 feet, probably. I don't know. Whatever it is, they can jump high, 7 feet. I haven't watched a high jumper since I was like 11. That's how uninteresting a sport it is. But anyway, so and we're supposed to expect that there should be the same number of people who can jump 7 feet as there are people who can jump 1 foot or 1 inch. No, we shouldn't expect there to be the same amount of energy in every single form, because it's a mechanical system and it can't run that way, just as an engine can't have an infinite number of revolutions per second. It's just stupid to think it would, that there would be just as easy.
Catastrophe where there's an infinite amount of energy at certain wavelengths.
It wouldn't be infinite, so that's stupid anyway. An amount, it'd be a lot of energy. If atoms produced the same amount of all forms of radiation, sure, then when you get to the higher frequencies, that means how far apart the bullets are. If the bullets are really, 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 really close together, you could have a million bullets in one tiny bit of space. But there's no reason to think you could do that in our physical universe, especially when there's a quanta of energy, the bullet size. The bullet size itself says you can't smash bullets that close together because the bullets would run into each other.
Like that can't be. So whatever, it turns out that
So whatever. I mean, this is all just so vague and mushy.
energy is quantified, which means that instead of being divided in space continuously, there's a point at which it's not divided.
So whatever that even means, it's divided in space. Again, there's really nothing, like I said, even in the historical perceptions of the reality, did anybody think, that light is energy is some kind of continuous thing, or that it's, the same piece of rock is going to hit me from every single location or something. I mean, everybody sort of understood that. No, you have to be facing something for the sunlight to hit you. You can't face the opposite direction and expect the photons to hit you.
And it's either in this pixel or that pixel of the Planck, the Planck region or whatever you want to call it. And it's a special weird thing that will...
Okay, there's no special weird except their model is especially weird. But that's it. I mean, their explanations are preposterous. Photons split in half. Photons have radar. Photons pull back their energy. Photons do all kinds of magical things, even though all the evidence points to photons being pretty much the simplest thing you can get. It's just such directed energy. And that it's the environment that makes photons do something funny. They don't do anything funny. If you shoot them through dead, quiet space, they just go straight. They don't do anything. It's matter that screws them up.
Deal with later. What's really going on that's not so weird is that atoms have a shape. When I was a kid, they were still saying, "Oh no, they're shapeless" or whatever.
They weren't saying that. So, I mean, I was a kid before you were a kid, and they didn't say any fucking such thing. They had a model, the nuclear symbol. They had elliptical orbits already. So, bullshit on you for that one. But this whole idea of this idea of electrons moving, okay, in my opinion, that's a Benjamin Franklin mistake. I mean, understandable because the solar system moves and the galaxy moves, so they have this idea that stuff has to move to maintain an orbit. But the truth is if we could do magnets in zero gravity and we could prevent magnets from flipping, we could create complex magnetic models. We could put a bunch of magnets in, north and south facing in space, okay, and arrange them in very complex ways, and they would stay in that complex shape, and nothing would have to move, because the attractive forces and the repulsive forces would act against each other, and everything would just balance. And we do that. There's toys that balance magnets, okay? I mean, you put two magnets in, put a hole through the magnets and put them on a stick, and they'll just levitate, and you can make more complex devices like two pieces of glass and put magnets in them and have them where the repulsive and attractiveness will keep them in tension, and you can make a shape, you can make some geometry. And I'm just arguing now, if it was easier to do, if there wasn't influences that were jiggling the magnets and disturbing them enough to break our big model, right? Because there are no big atoms, right? Their atoms are confined to a certain size and they can't get any bigger. And then they become radioactive and decay and fall apart. For the very reason I'm describing, essentially. Is there's too much jiggling, too much movement, and the thing jiggles itself to pieces. And but there's no reason, okay? There's not some volume of evidence that compels you to believe that the negative element needs to be in an orbit. The force is different than gravity, and you wouldn't expect the same orbits anyway.
This is a neon atom. What are we looking at? This is a neon atom.
So this is just their made-up conception of a neon atom. It's based on tiny shreds of information. They don't have any image of a neon atom. They have no real-time, especially image. They have composites that are made up over time of what does the atom usually look like. But that's the best they can do. Is a vague idea of where the what you're seeing, and what you're seeing is that what is average a million atoms. What's the average look like? That's what they can sort of get some information about, and this is what they draw is an effort to model that to fit the evidence. But they're going in with assumptions that I have to keep these electrons moving, that I have to do this and I have to do that. So they're adding conditions that are, in my opinion, false notions that you don't have to start from that point. And so there's no need for this. You could just say the average position is here, where the little lines are going through, and just put it in that position and say that's where its average position is based on the energy of the atom itself moving and such. That position will change, but it's not changing relative to the proton. It's just changing relative to our ability to sense it or to detect it.
Nucleus is down there at the center, not really even visible. And then what we're looking at is the electron shells. That blue one.
The shell would just be a representation, in my opinion, of distance from the positive net charge in the nucleus. So there's a positive net charge in the nucleus. The electrons are attracted to it, and the only thing that stops them from getting to it are the other electrons that are saying you can't get here. And the neutrons in the nucleus that are also part of the nucleus play a role in the sense that they contain an electron and a proton, so the electrons in the neutrons are probably doing some repelling also.
Is the first shell, like that's the shell that a hydrogen atom has, and it can have 2 electrons in it. If it were to get excited in a hydrogen atom, it would splink out into these other bubbles, right?
So it would blink out, it would splink, it would do some magical thing, blah 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 blah. Where what I would argue happens is electrons move, and when they move, they're moving into tension. They're moving into something that's already in tension. So if I have 4 electrons from a distance from the center, 4 magnets, with the same poles facing each other, and I add another magnet, that means all the other magnets will have to adjust their position because of the pressure. So the pressure will be felt by all the magnets. So you can just think of it magnets in a row, or as I gave the example of magnets levitating. If I stick another magnet in and keep the same amount of space, there's going to be a change in the distance between them, obviously. And my argument is there's going to be a change in the pressure then. If I force them to stay in the same space, I will feel the extra pressure of adding that extra magnet. So if I have 3 magnets stacked on top of each other on a stick, and I force another magnet in there, put another magnet in, keep the same distance, I'll feel the pressure difference. And the fact is it's going to want to expand. And the same thing happens in atoms. So when you move an electron from one location in here to out here, you expand the pressure. So wherever the electron goes, it expands that ring, that area. And when that expands, it causes an implication of everything else having to expand. So if you expand the inner ring, all the other rings have to expand because the pressure is felt by all of the electrons eventually. So if you mess with the outer ring, it's not going to affect the inner ring. But if you mess with the inner ring, it's going to affect all the rings.
A bubble, like a magnetic soap bubble. That's the electron, that shell.
So blah, 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 blah. So he's saying, okay, that's the first orbital, and this is the second orbital, and this is the third orbital. something like that anyway. But these are ambiguous, right? I mean, the electron could be anywhere in this whole sphere, and then all of a sudden the spheres start getting very eccentric, and I'd say that's just rubbish. If we had better vision, we'd see that it has to be, the symmetry is, the geometry is more rigid than this. There are specific positions, and the shape ends up being a composite of where the electrons are and how many you can have. You can have 4 of them on over here if you have one that's really close over here. So there's one that's close to the proton here, and there's 4 that are further away from the proton here, and that force would end up being equal. It's that kind of geometry.
And 2 electrons can contribute in there and join together and act like a boson. And then there's another.
So it acts like a boson. In what way does it act like anything? Yeah, please explain what it, where you get that notion that it acts like something.
Shell that's spherical, this red one, and then after that you have these P shells, which are these dumbbell shapes, or there's 3 of them here for the 3 dimensions. One this way, one this way. What we're looking at is neon, where all of these shells are filled. Each one is a pair. 2, 4, 6, 8, 10 electrons. And that's neon. And its electrons are all filled up, so it doesn't really want to react.
All right, so this argument is sort of consistent in the sense that I would agree that obviously if you have low pressure, because you're missing an electron, you haven't filled the ring entirely, then it's going to be easy to pop a new one in, okay, to that ring and maintain a better distance. Let's see, what's a better way to say it? But the idea of a shared electron, the idea that what really connects chemistry to chemistry. Now, their idea that a shared electron is there's 2 nucleuses here and here of the 2 atoms, and somehow the shared electron is traveling around both of them. And somehow that's enough of a bond to hold them together. When you say that 99% of the time the electron isn't well bound to either atom, 99% of the time it's poorly attached. At least 50-50. And so these bonds wouldn't be very strong at all, where if the bond was an actual physical sharing, that is, there's a ring of 8 electrons here and there's a ring of 8 electrons here. Now there's really 7 and 7, and they're sharing the 8th one. So there's 15 instead of 16 kind of thing. And it works. And when one pulls away, one will pull away with the electron, and the other one will pull away minus the electron. So one will have 8 and one will have 7. And that's exactly what we see. So, what makes more sense? All of that motion inside of these atoms that are durable. They're created under very high pressure, and they're the only things, these 100 configurations, are the only configurations that can survive outside of that pressure. And he thinks it's made out of all this stuff going in all kinds of directions all the time, and that somehow that would bond it together strong to make a piece of steel, for example. I don't think so. I don't think there's a chance in hell that's how it works.
With anything. Because the thing is, when one of these little nodes has just 1 electron in it, it wants to pair up. Whatever reason. If this shell bumps into another shell,
for whatever reason, it wants to pair up. Again, this is so vague. There has to be a mechanical mechanism why it is necessary. And again, he's basically saying that all 6 of those objects, those orange objects, or yellow, are somehow deficient. And that's not what really is the issue. The issue is that one of them is missing. One of those lumps is missing on an atom, and that's what makes it reactive, because it's got a void in the geometry that makes it weaker.
Where there's only 1 electron in that shell, it'll want to connect. So a hydrogen, if it bumps, so this is 10. When you have oxygen, here's another way of drawing it. This has, these shells all have 2 electrons, and the pink and the yellow have 1. So if another oxygen comes up here and it's yellow or pink, bumps into this guy, they're going to want to share an electron.
Just saying stuff, right? I mean, that doesn't make any sense. Logically, it doesn't say anything about how it's really configured. And clearly, we also know that these atoms end up being kind of, they have shape. You know, that one side looks a little different than the other side. And that's how you get them into all this complex geometry where I can take something like carbon and I can make graphite or I can make a diamond out of exactly the same atom. And I can only do that because the atom does have a shape. It's not just some round object. You know, it is shaped. It has a lopsidedness, in the sense as I'm pointing out or attempting to point out, because depending on where the electron is, how close they are to the proton, the protons, you can have more on one side than you have on the other side if the ones on one side are closer and the ones on the other side are further away. You can have a lack of symmetry in an atom. And that's what makes them unique. That's what makes them not unique. That's what makes them different from each other in terms of their reactivity.
So they'll spark together.
Spark together, la la la, la la. Whatever that means, again, they'll spark together.
The electron from the hydrogen or whatever the other atom is will start to flow in and around the nucleus of this. You have what's called a covalent bond.
Right, so that's the figure 8 nonsense that attempts to say that somehow they're sharing something and that is tying them to each other, yet there's no explanation for exactly how those orbits would ever be created, in the sense of how they'll be maintainable. They're very weak, and so it's like the comets that do fly through our solar system. Their orbits are weak orbits. All you have to do is nudge these things a little bit, and they're gone forever. They're never coming back. So, you know, this whole idea that you can maintain attachment at great distance, no, you can't.
And this pairing is satisfied by sharing an electron.
So another point to make is that the electrons aren't really moving the speed of light, so they're moving much slower. And in all that time that this thing is figure eighting, you have to recognize that there's all kinds of other forces, heat and all kinds of other stuff that's tending to move the protons into different locations. So how could, you know, these orbits be maintained if the nucleuses are moving? Just seems highly improbable that that would make a durable atom.
Both of these satisfy the pairing, even though there's still an electron missing, right? So when an oxygen hooks up with 2 hydrogens, the oxygen gets an extra 2 electrons, so it fills out to the 10 that it wants. And
I think he meant neon or something. The hydrogen fills out to 10. I don't think so.
And the hydrogen,
The oxygen
which was at
doesn't
1,
have 10.
fills out to 2, which it wants.
So it already was at 2. So you have to have an ion somewhere. You know, you have to have something to make that happen, where they are forced to share. That is, you have to kick something out. So you make one of them dependent on, you make them dependent on each other. So first you have to make them dependent.
However, they're sharing electrons with each other, and since the you know, there's a lot more positive charge inside the
I mean, a rocket engine produces, you know, hydrogen. You know, the ones, the space shuttle and shit, burns hydrogen, right, by oxidizing it, and you get a big flame. The big flame is basically pointing out that you have to take something out of one of the atoms to make them stick to each other to make water. So making the water requires you to lose somebody's energy. You could argue electrons have to go, and with them the force that's binding them.
Oxygen, the electrons that are going, when there's essentially 10 electrons flowing around it, there are too many. There's an extra attraction back to the hydrogen.
I thought there was 8 for oxygen, so I don't know what this 10 thing is, but whatever.
So what happens is these magnetic soap bubble electrons, they're not exactly evenly shared, and it creates the polarity of the water molecule.
Well, they're evenly shared in that they're always obliged to find a neutral environment. That is, the force being applied from one direction to the other direction has to be equal. There has to be as much attraction as there is repulsion, and the attraction has to be made even by that mechanism, by combining repulsion and attraction. There has to be some place where they say, okay, I can move a little this way, but then I feel more force pushing me this way, and if I move this way, I feel more force pushing me this way. And that's where everything ends up. And that's the moment to moment. That's what the universe looks like. Everything is in a position that makes sense based on the forces that are hitting it, that it would stay in that position for any one moment. And then things can push it, okay, over time in a direction. And you could notice that because at any one moment there's one extra quanta comes in and pushes it and pushes it and pushes it, because there's more force on one side than the other side, or there's less attractive force than there was before because something's blocking it or something absorbed the momentum. Probably could have paused to do his research. An incognito window. I guess that's how Chrome calls it now. Yeah, they copied Firefox. Incognito window. Why would he need an incognito window? Kind of funny. I mean, you know, for this kind of stuff. Okay, he clicked on something else, so I guess he didn't need that.
The oxygen becomes slightly positive and the hydrogen slightly negative. Is that right? I always forget. No, it's the other way around. The hydrogens become slightly positive because they're sharing their electrons.
Again, well, talking about the bond without talking about how it's actually created, that is, doing before and after is fine as long as you count all the little bumps before and after and realize that there's a bump missing.
A way to something that has a greater positivity than themselves. And so the math all works out about how the charges spread out.
So I guess he was showing the wrong image. He was showing water molecules sticking to each other, not hydrogen sticking to oxygen.
And one reason that it's pulsed looking like this, these bubbles, is because these bubbles are all negative, so they want to stay away from each other, right? The bubble would like to stay, and there's no
bubble, there's an electron, and the electrons repel each other, and the repulsion is made of something. There's a real force bouncing between them. There's ping pong paddles and there's ping pong balls. And the balls are the force. They're the thing the photon is made out of, the gravity is made out of, and the magnetism is made out of. They're the force, the one universal force. And the force can be at a frequency, or it can be polarized in the case of magnetism, or it can be neither at a frequency and not polarized in the case of gravity. And I would say that gravity can have a frequency, but again, now we're back to the trick of how do you detect a piece of electromagnetic radiation. And the truth is, you have to have a stream of it. You have to have more than one quanta. If you have one quanta, you got nothing. You got no frequency. One bullet can't be detected electromagnetically, and a certain minimum is necessary. For our human eye, 6 bullets need to hit before you say photon happened. And for other instruments, it might be 3. Maybe the best we got, a photo multiplier, might need 3 bits of energy, 3 quanta, before it says, photon. And if there's less than that, it can't see it. And so if there's less than that, that could be gravity. Gravity is a bunch of little rays of electromagnetic spectrum.
Threshold where it stays away from each other, but is attracted to the positive in the nucleus.
So again, I'll just rephrase. Now, all you people who are convinced that this crap is true, it's only true as an attempt to take a tiny bit of evidence and make a model that's durable, that works for explaining things. Now, when they attempt to make their model work, they have to say things like it poofs the energy, because they have no explanation for where the energy comes from, for gravity or magnetism. No explanation whatsoever. So just understand, there's a tiny bit of evidence, and all you're trying to do is create a model that's durable in terms of not only explaining the evidence, but explaining what you need to know is, where did it come from? Where did the energy come from? Certain questions like that. And I'm saying their model doesn't do it. The simple model of understanding there's force in the universe already, lots of it, the cosmic background, radiation times 1,000,000, and that is what we feel is gravity. That, when it goes into an atom and gets shot out in a frequency, is what we see as a photon. It's not virtual anymore. And when that's segregated, because there's 2 kinds of them, black and red, plus and minus force, electron force, proton force, reflective force. When it's segregated, we have a bipolar magnet. Theirs doesn't explain any of that. By just turning it into what it appears to be from the evidence, and what the big universe does show us, gives us some example of, it's a material function. It's a bit. There's clumps of stuff moving, and that's the nature of momentum.
Yes, and is connected through this Cooper pair system where these things want to pair up.
So more Cooper pair system where they want to pair up. So now we have to go look up Cooper and find out what Cooper's addition to this bad model is. But it's a bad model. It doesn't explain anything. It leaves everything virtual and vague. And everybody falls for it because all the eggheads say so. But they don't say so for good reason. They just say so because it's all they can conceive, and they haven't been very open to any counter arguments, and for some good reason. Just because most of the people who wish to critique something wish to critique it for dishonest reasons. Creationists, for example, frauds, people who just want to make money on lies and deception. They want to promise they'll cure your cancer, and so they need a theory of curing cancer. Some reasoning, some bias that has generated an interest they have in promoting something that they really have no evidence to back up. It's just like going to a jury trial where you hate the guy, you think he was a shitty human, and you're going to say he's guilty whether he's guilty or not, but you just think he deserves it.
So in neon, where it's already paired up, it doesn't want to react with anything. In oxygen, there's 2 of these waiting for a pair, so they're ready to share electrons. And then you have a Lego system where things plug together. Now in the oxygen is
a Lego system. There's no Lego system here. Nothing he's just describing has anything to do with Legos clicking together in kind of an easy to understand mechanical way. So again, this is just part of the hype and the propaganda, is to make analogies to things that just can't be analogies, because there's nothing LEGO in their system.
Carbon is only 6, so the issue there is that carbon wants to be shaped just like this as well, but the problem is, so oxygen has one.
It doesn't really want to. It's perfectly comfortable not being. Okay? Not having stuff in balance in some place, like having stuff not on the scale, doesn't bother the scale any. The scale just demands to be balanced, that you have to have the right stuff in the right positions. So that's the only argument here. You don't need to have. You have scales that have big plates, and you can put stuff in the middle of the plates, and you put more stuff over here and more stuff over here. Well, if you don't put more stuff over here and here, it's not going to matter to the scale. The scale's still going to say I'm balanced. So this relationship between protons and electrons just has to achieve a balance. It can be balanced in a lot of different ways, in more than one way. And that's why there's a variety of atoms, is because you can balance them in different ways.
One electron to put in this and one electron to put in there, and so they're all produced, but two of them are wanting partners. Well,
they're not wanting them. Again, they'll accept, sharing an electron in that location. That's all.
Problem is with carbon is there's only enough electrons to go ahead and put one of these in, and so it becomes a hybrid when you add the waves together from all of these different shapes of the.
So when you add waves together, so again now it's again more mush about, so it's generating waves, it's generating some kind of stuff, and we don't see that. All it can generate essentially is a reflection of what goes in. So if it's in a hot environment, it'll reflect that environment, and it'll add a little nuance to it, being its spectrum. Based on the pressure of its bits, it will give back pressure. And so if it has high pressure at one electron, that electron will reflect different than the low pressure electron. A tight trampoline will bounce something different than a relaxed trampoline. That's simple an argument. The same energy goes in, but because the electron's in a different pressure state, it reflects something different. So the electron in the middle and the close to the proton is going to reflect different than the one further away, and depending on how much stuff is in that ring is going to depend on how much pressure there is. And so it's all about pressure. And the pressure is the ping pong balls between the paddles. There's a whole bunch of paddles and a bunch of ping pong balls, and it all has to balance out.
Electrons that are coursing through this whole thing as a circuit, you end up with.
So again, they have no hard evidence for any of that. They have nothing. They have just little tiny specks of facts to have to put together. So again, this is a connected dot picture where you got not too many dots, and so there's 1/10 of the amount of dots that would make it easy to just see the bear's image. Instead you have 1/10 of those, so the bear can look like a lot of things.
This tetrahedral distortion, basically, of that shape, which is, again, like oxygen and hydrogen, very reactive. They want to share all of these guys. See, they all have one, so there's 4 contact points where if an electron from a hydrogen or an oxygen shell bumps into this, it'll connect together, and they'll.
So again, part of what makes something easy to connect to, and you can understand sort of, is that as long as there's not a whole bunch of electrons that are going to be competing, that are going to be creating pressure to push something away before it gets there. So if the environment's quiet, then it's easy for something to get to an electron to share it. But if it's not quiet, if there's a lot of force pushing away, then it's going to move away rather than move in. And so it's really about how much noise there is going in, whether or not you go in the door. If there's if there's a door sitting there and it's making a bunch of wild animal noises, you might avoid going in that door. But if it's nice and quiet, you might think there's a seashore in there and it's nice and pleasant, then you'll go through the door. I don't know, silly analogy, but
start sharing oxygen. And this is what causes the molecules to bind together. Now, when you shoot energy into something, like if you shoot energy into, let's say you had this blue shell with one electron, that would be hydrogen with an electron. If you shot energy into it, it would bang, 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 it would bounce out. The extra energy would make it go into this P shape. First this one, and then
so I think he meant neon. He said hydrogen, I think. So I mean, I don't know. Bing, bang, bang. Okay, not very good. Uh, you know, clearly, energy affects the position and shape of these atoms. So if you can hit them with the right energy or enough energy, you'll change what they are. And that's the whole phase argument about, the resonant frequencies are really a description of distances. So at certain distances, certain energies will make it possible to break something's shape or reshape it. So it's a tipping point kind of argument. A certain energy provided in the right form will have an effect. Energy in the wrong form won't have an effect because it's a pressurized system vulnerable to certain influences.
This, and eventually at a high enough state, all of this. And every transition, as it dropped back down to the blue shape, would release photons. Various, very distinct photons that it can release, right?
So kind of vague again. It releases them how, through what mechanism. The pressure goes in, some pressure comes out. You have to explain how the pressure migrates through the system. There's no explanation of any of that, so it's just very vague.
And these energies are also related to what's binding these things together, and what's creating this kind of Lego structure that allows things to hook together.
Look, we know that these atoms have a tremendous amount of energy in them, the pressure. So the pressure was in the sun that created them. The pressure is in the atom, and it stays in the atom. That's the point. So you move the atom out of the sun, and it maintains that high pressure inside the atom, essentially. So that's where all the nuclear energy comes from. That's why the nuclear bomb makes so much energy. It's because there's a tremendous amount of tension inside the atom. So there's a lot of force trapped in there. So when you move one of these things out, these electrons, you end up releasing a lot of that pressure in the form of the force, the little bits moving the speed of light, the radiation.
They're at different energies based on the shape of an atom. At a high enough energy, pumped with energy, it'll be bleeding photons, but you could keep pumping energy.
So again, it doesn't. First, it bleeds an electron, and the electron is ejected at a velocity. So when you eject an electron, create an ion, you're ejecting the electron at a velocity. Well, it only has a velocity because there's force pushing it. So it's the force that's pushing it out. So you take a tiny bit of energy, you push it in. And you disturb the system, and when you disturb the system, you can release much more energy because you've taken some of the pressure out of the system.
To hydrogen, and it kind of creates the shape of an oxygen atom, both just with one electron, and therefore each of these connections is more faint. Yet if it hit another molecule, it could do this connection, which explains some of the differences of high energy physics.
Well, it explains it very poorly. Clearly the alchemy thing is difficult and only happens when you create very high pressures. So you have to bombard the atoms with a tremendous amount of pressure to actually transform one element atom, one shape, into another shape. because you have to keep the whole thing from falling apart, and so you have to put them back in the sun essentially to do your alchemy.
And this is how things plug together. And when this high excited state of hydrogen falls back into its low energy, here the blues.
So I guess he's saying these are hydrogen atoms that are making this up, and that's not entirely untrue, but clearly they don't have a individual nuclei. So, to say that you could reduce this into hydrogen atoms, I would agree. You probably can take any atom and make hydrogen atoms out of it eventually. But what he just described, he's looking at a neon atom and he's talking about hydrogen atoms, which is a mistake in my opinion.
Orbital state. A photon shoots off and it goes off in a spherical ripple.
All right, so there's just no evidence defending that as being a rational explanation. It goes off as a spherical ripple, but it only lands in one tiny location in space, and the rest of the spherical ripple somehow becomes meaningless and irrelevant. It just doesn't make any sense. It's not logical. It doesn't fit the evidence. It's nonsensical rubbish. We know the momentum leaves in an angle, in a position, a ray, a vector. It has a vector and it travels that vector. This is just crap. This is a crappy model, and I don't know why people would defend it. It's a crappy model.
Because of the Planck constant, the energy can't be divided infinitely along this surface as it grows continuously. And the energy has to be located at a particular point on there.
So he's attempting to make a rationalization, blaming it on Planck, and saying somehow the Planck constant somehow explains how you take something where the energy is spread in all kinds of locations, and somehow all the energy ends up in one location. Instead of explaining how that could possibly be true, he just blames it on Planck, because Planck figured out that no, the energy lands in clumps, little clumps of energy, little clumps of momentum. The momentum can be broken into clumps. Those two things really don't have, this story he's telling really isn't Planck's fault. So, and Planck didn't have any explanation for this crap.
When we detect it. If we detect it, we are entangled.
No. This isn't about detecting it. It's about it landing somewhere in a form that we can know that it landed. And as I just pointed out, photons, we don't see a ton of the photons because their ray length is too short. So our capacity to detect is kind of bullshit. And clearly every detection is a grotesquely active interaction. It's not a detection. We crash the photon right into something. I mean, you can't crash a car into a brick wall and say, I'm doing car detection. I mean, is that sensible way to describe something? I'm detecting by crashing the car into a brick wall. I detected that cars exist? Now, come on. It's silly.
With that solution, but all of the other solutions still exist, and other things in the universe.
Well, they clearly don't exist. So clearly, once the car crashes into the wall, all the other cars that were going in all the other directions don't exist anymore. There's no evidence they exist. There's no evidence they continue to exist, or if they existed ever in any physical form that could ever be detected. That there's no car. So that's just more garbage. They don't exist anymore.
Universe are entangled with their other solutions.
There's entangled with other solutions. Again, there's just no evidence in our physical universe of any instantaneous action. None. So this is just made up garbage. It's not rationally founded. This isn't logical.
No multiverse. We're all one universe, but elements of matter and energy are entangled with.
No, I mean, it's supposed to be energy entangled with energy, or matter entangled with matter. There's not supposed to be energy entangled with something else. This is just This is just a fairy tale. This part is just overtly made up. There's just no evidence for any of this crap.
Different elements of energy and mass and so on.
And so on and so forth and whatnot. Well, yeah, and vague as could possibly be, evidenced with nothing, no experiment cited to demonstrate any of this crap, and no rational reasoning for the consequences of it. How the hell could this possibly make sense? The car just crashed into a wall. The invisible cars still exist and they're still doing something and they're entangled with something? What are you talking about?
What's really going on is that you have all of these rocks and things bumping into each other.
So there was no rocks in his description at all. I mean, I guess you could say his electron theory is a rock, but he has no rocks describing the photon. The photon was some kind of wave of crap or something. Some who knows what. Where was the rock?
That are entangled. But they get disentangled rather quickly. So, for example,
they get disentangled. Well, as I understand it, they can never be disentangled unless you destroy one of them in a black hole. So, how does that even make any sense? They get disentangled. No, they get separated by distance. They're still entangled. That's your theory. That's their theory. I mean, this is so, like I said, this is so not the standard model. So he starts off defending the standard model, and then he goes off on his own tangent of, I'll just make this part up.
When somebody steps on a beach, they leave their footprint in the sand. The shape of their foot is entangled, literally quantum entangled, with the sand, which is in that shape.
Again, there's absolutely no necessity to believe in entanglement to explain the dent in the sand. The fact that physical things move physical things through a momentum process, a force process. What does entanglement have to do with it?
And is containing that information of the shape of the foot that stepped in it. You can do the same thing.
Containing the information how, besides being in positions that will change once the wave comes in and wipes it all out with new energy? What's entangled? What?
With a rock, rolls down the hill in a little landslide, lands on the beach, and leaves its imprint in the beach. While it's still sitting there, it's made its imprint in the beach.
And after it leaves, it's left its imprint until some other force, as Newton would say, comes along to change anything. You have to have a force do it. Something has to physically, forcibly force something to change. It doesn't change on its own.
Entangled information. The thing is, as time comes and the rock is washed away and the sand is remixed, the information of how the rock got there and the path of the rock to get where it is now, and that's all erased. Right, which is the same as
Okay, so again, this is just silly in the sense that erased is what? A fact of history? No, it's not erased as a fact. That's how it got there. It had to have a path, and that's the path that the little force bits made possible. Other paths weren't possible. It didn't bounce off Venus and then come back down. Lots of things couldn't have been the truth. So there's certainly the history is a fact. There's only one, all roads don't lead to Rome, kind of thing. I mean, only certain paths will get you there. Going the opposite way won't get you there. And so history requires certain things to have happened. There had to be an Eve for the human race to exist. There had to be something that gave birth to the first human.
Entanglement. When you erase information by randomizing it, by shredding it, but truly shredding it beyond, putting back together, You
How would you put it back together anyway? How would you reverse a zillions and zillions and zillions of tiny interactions? You can't do any of that. So why would you waste time worrying about it? It did happen a specific way through specific environmental circumstances. Period. That's all we need to know. What is all this woo? That somehow we have to believe something else, that there's some magic to it when it's physics. There's no, the solar system, again, it gives us evidence. Everything happening in the solar is so clockwork. It is so frickin' clockwork, so precise. Every little movement can be understood, measured, confined. It's clockwork. There's no woo in the universe. And there's no woo in the microverse. The real universe. The real universe is the smaller verse. That's the place where there's really an end to the discussion. There's empty space and there's bits. And some bits are moving the speed of light and the other ones are being banged around by the stuff moving the speed of light.
it's the same thing as an unmeasurement. You are information, you had entanglement, and you are removing.
Unmeasurement. So now we're supposed to have a new word, an unmeasurement. Why do I need this in my vocabulary? Why do I need the word unmeasurement? Unstinkification. I need to have that. We just make some new stupid words. You're an honest person. you're uncorrect. Yeah. An uncorrectophile.
The entanglement. And, the second law of thermodynamics with the entropy is that entanglement tends to...
No, the law of thermodynamics is another illustration of the precision of the universe. And the fact is that you can account for all this stuff. And the momentum has to move from point A to point B for point B to have energy. And you can account for it.
Disentangle. Right, but the human brain with the entropy pump and all other living creatures.
Again, this entropy pump word like that means something. No, it doesn't mean anything in physics. It's a battery. It stores a lot of potential energy and then it acts kinetically based on stuff hitting it. And it responds to the stuff hitting it. That's what our brain does. Influences in, mechanism gets sprung, action out. But that's all there is. There's input, output by regular, consistent dynamics. No woo required.
Seem to maintain that information, right? So we maintain the entanglement.
There's no entanglement. We maintain neural connections, patterns. Pattern butterfly, pattern asshole, pattern jerk. Patterns are in my brain of neural connections. And those patterns are revisited in the system when I'm triggered by some kind of algorithm in my brain that mathematically figures out there's an element of butterfly in regular fly. Yeah, they have something in common. The word fly.
We maintain the consequence of one thing happened and then another because physically we are remembering or maintaining our connection to information that physically happened.
And we're doing it by creating a model of the reality. I don't have butterfly in my head. I have a model of butterfly in my head. It's not butterfly. I'm not entangled with butterfly. There's no direct connection at all between butterfly and me. There's only the connection of I've seen light reflect off a butterfly. And I've seen the image of a butterfly. And that's fundamentally the most of my information. Now, if my brain works on it for a while, it'll resolve the hairs on the butterfly and figure out, oh yeah, they're kind of like feathers, and blah blah. And it'll do lots of detailed work, and a little mouthpiece that rolls up, and it'll have lots of other information, but all of those models are not in any way directly related to any one butterfly or to any physical thing, except I've received images and I've read experiments or I've read other stories about what butterflies do.
And so when the photon goes out in this bubble, we are getting...
So again, electrons produce photons in directions. And over time, and over volume of electrons doing the same thing, it can look like a wave. But the individual bits are not waving at all. They were deliberately placed through vectors in their locations.
Entangled with it having arrived at a particular point, but in reality, that's just because since information has discrete quantified, quantified.
So information, again, just this vague notion of some notion of information. No, there's actions and reactions. There's no information. We can make models, and we can call our model information. Fine, I suppose, but that's not what they're doing. They're just throwing this word information out there as if there is some kind of thing called an information ton. His video is titled Philosophy of Tons, and yet he'll use a word like information. There's only models.
Amounts, it has to exist in a particular location as opposed to being infinitely devised by the surface area of an expanding,
So just absolute mush. There's just no expanding any of this. Again, I'll use the soldier example. I send one soldier, you're going to say, oh yeah, it's a quanta of soldier. There's no frequency, there's just one soldier, right? Now if I say 10 soldiers lined up next to each other, then maybe you'll see a front. And then if I have a second row of soldiers and a third row of soldiers, well then you'll have this impression that I'm waving soldiers at you. But I did exactly the same thing. I just sent one soldier at a time. I just sent individual soldiers. There's no wave that's anything other but an emergent consequence. It's not a fundamental element. The wave doesn't move something. The wave doesn't do any of this. The soldier does. The quanta does.
Spherical wave. So, Ann Pelosi was going to say something.
Yeah, whatever. More, garbage. Again, it's just kind of funny to say. I mean, not that I'm for corporate Democrats, but the alternative of open border, everything will be just fine. Let's just deficit spend. Democrats, so much worse. So much more insane. Welfare for everyone. Fuck anybody having to be productive. Who wants to do any of that? We'll just keep exploiting foreign people until the foreign people own the country. So fucking stupid. Well, they won't own it. They'll be insanely indebted. That's all they'll create is more debt. Anyway, with their 400 kids. Anyway, there's no point in making commentary on politics here. No point in making commentary on politics anywhere. People are just stone cold brain dead. The comments I read are just a glimmer of just how fucking stupid people are. Anyway, till next time. Enough commentary. Maybe I'll try doing this icon thing instead of hitting the button. Oh, I gotta do it this way. Alright, I guess we'll just save it.